So sometimes we need to solve for one variable in terms of the other and find the inverse function, basically. In here, I have a z equal to square root of r minus 1 quantity to power 2 minus 1, and I want to solve for r. First of all, the way it is right now, square root of r minus 1 to power 2 minus 1, you cannot distribute square root over any of the terms, and you cannot simplify that negative 1 without expanding r minus 1 to power 2. Here, I rather not expand at all. I don't want to expand r minus 1 to power 2 into r squared minus 2r plus 1. Why? That is true. This is an correct statement, but I don't want to use that. Why? Because solving for r is easier without that expansion. And how do I solve for r? First of all, I go everything to power 2 to get rid of the square root, and I get z squared is equal to r minus 1 to power 2 minus 1. Then I try to isolate r as much as I can, so I add 1 to both sides. Now that I'm at this point, I want to take the square root of both sides. And z squared plus 1 is always positive, so that's a nice thing. And then what I get is going to be r minus 1, but I don't know if r minus 1 is positive or negative, so I have to have a plus and minus in here, equal to square root of x squared plus 1. So the to power 2 and square root go away, but I end up with absolute value. That's why there's a plus and minus in here. Take the plus and minus to the other side. It's just easier to deal with it on the other side. And then solve for r by adding 1. So plus minus square root of z squared plus 1 plus 1. So the solutions actually was not entirely a reversible function because I'm getting two solutions. I'm getting r equal to square root of z squared plus 1 and r equal to negative square root of z squared plus 1 plus 1. Therefore, I needed to actually do a little bit of a domain restriction to do this. But typically, when you're doing a problem that requires reversing, they will tell you which piece or which constraint of the domain that you're using to reverse the function. So go with that after.